Hi, welcome back to the part 5 of learning how to draw Lewis dot structure. Now in this tutorial, okay, if you watch all the tutorials, the previous parts, you should learn how to draw a Lewis dot structure already. And in this section of the tutorial, what we will learn is that, well, in part 1 we talk about carbon dioxide. Okay, we talk about drawing carbon dioxide Lewis dot structure, and at the very end of the tutorial, we talk about how this is the only structure possible, and we are not going to draw these two. Okay, and if you learn how to draw a Lewis dot structure for water, or if you learn that in biology, okay, you learn how to draw the Lewis dot structure like this, but not like this, not like that. Well, there's a reason behind it. Okay, and in this tutorial, I want to explain to you why there is only one particular way to draw Lewis dot structure. Okay, there's a reason for that. Okay, now I want to start out with teaching you with one term, one chemistry term. This term is called electron density. Okay, so electron density. Now, before I tell you the definition of electron density, I would like to help to introduce to you how to count electron density first. And then I want you to see how you get the idea of electron density. Alright, so let's start. So for this example, okay, this is the correct drawing of the Lewis dot structure of water. So we only focus on the electron densities around the central atom. Okay, because that's how we determine the shape of an atom. So now, let's do the counting. This will be considered as one electron density. This is considered as an other electron density. This is considered as the third electron density. This is considered as the fourth electron density. Okay, so I hope you're following so far. Now I'm going to show you another example. Okay, I'm going to draw methane here real quick. Okay, so let's count the electron density. Okay, you can take a guess on how many electron density here for carbon, around carbon. We have 1, 2, 3, and 4. 4 electron densities total around the central atom, okay, for methane, for carbon. Alright, now, maybe you have some idea right now. Let's look at the carbon dioxide right here. Carbon is the central atom, so we're going to count the electron density around the carbon. So let's start. 1 electron density. This will be the second electron density around the carbon. So you may be thinking, well, I thought it was just like 2 electrons per electron density. How come there are just two electron densities around this carbon? Well, the definition of electron density is actually not related to the quantity. It's more on the location of electrons. What we mean by electron density is simply like group of electrons. It's a group. Okay, physically together, okay, as a group. So we have 1 group, 2 groups, 3 groups, and 4 groups total around this oxygen. So lone pair electrons, they are paired, so we count it as 1 electron density. The single bond right here, they are together, 2 electrons together, we count it as 1 electron density. And here, what we have is the double bond. Yes, there are 4 electrons, but these 4 electrons are together. Okay, these 4 electrons are together, so we consider this double bond as 1 single electron density. This is the reason why there are 2 total electron densities around carbon. Now you may ask, why is it so important to learn electron density? I didn't hear this in school. So why do we have to mention this? Well, you have to consider a fact that electrons are negatively charged, and this is going to help you understand about the shape of electrons. Now in school you may have those like spheres and stakes model to help you understand the shapes. Now what I feel uncomfortable with those models is that, well, you have those holes and stakes like pre-designed. So it makes students very difficult to understand why it is like this. Now I'm going to make some tools that's very simple, and you have it in your on your table already. Let's get some pens or pencils or markers or whatever. Okay. So now I'm going to do this example. So consider my fist as the carbon atom right here, and consider these two markers. The marker right here. These are my double bonds. The caps will be considered as the oxygen atom. So now let's consider this structure. So this is my carbon, okay, and then I'm going to put it like this. So this is analogous to this structure. Now what I want you to think is this. These are electron densities, okay, and these are negatively charged. What happens if they are so close together? Okay, I want you to think about this. What happens if they're so close together? Now, the reality is that when they are so close together and they are all negatively charged, since they have the same charge, they would naturally repel to each other. Okay, so naturally they will repel to each other, and now the question is, when would they stop repelling, or when would they get to an equilibrium position? Okay, so now think about this. Consider this shape. Okay, this is my fist, the carbon. The caps are my oxygen. These are my electron densities. So now what we have is the same angle or distance. Okay, you can think about it as a distance. The same angle between the two electron densities. And in this position, for the in this orientation of the double bonds, well, the electron densities would minimize the repulsion. Now, if we go this slightly, go upwards slightly, squeeze them together, then there will be more repulsion in here, less repulsion in here, and that's not equal. So therefore, it will repel each other again, and we get this shape. And this is the reason why we have a linear structure for carbon dioxide. Now, let's consider the methane example. So 4 bonds around the carbon. So therefore, let's get 4 markers. So forgive me that I have different colors, but let's just treat them all the same. Okay, the caps are my hydrogen atoms, and the marker itself, the stem itself here, is the single bond. So now you would consider this. Okay, now at the very beginning, a lot of people would consider this 90 degrees angle right here. Okay, you see it? Now, I want you to see it in a different way. You see the 90 degrees angle here? What about this? What about this distance? What about this angle? This is a 180 degrees angle. Well, we have these 90 degrees angle right here, but how come this is 180? Well, that's not equal. So therefore, they will repel each other to minimize repulsion. So what happened? Well, this is just 2-dimensional. And naturally, what will happen is it will go 3-dimensional. So what happened is they will repel each other, they keep on repelling to make sure the distance will be equal to each other, like this. Okay? And this is how we get tetrahedral structure. Okay? See this? One face, second face, the third face, and the fourth at the bottom. And that's why we call it a tetrahedral, a shape that has 4 faces. Okay, now let's consider another example. Okay, another example would be BH3. Okay, boron trihydride. For BH3 here, the Lewis dot structure is going to be BH3 like this. Okay, so let's have only 3 electron densities. Okay, 1, 2, and 3. Okay, have your pencils or pen ready. So 3 electron densities. How can we minimize the repulsion between these 3 electron densities? Well, if you learn the geometry, a circle that has 360 degrees divided by 3 equally, you have 120 degrees each. Okay, you see this triangle here? And now you look at here, it's a plane, okay, flat. So this is why we call this trigonal planar, okay, geometry. Okay, now I'm not going to talk about a lot on the geometry in this section because it will be a lot more to explain. But in this tutorial, I would like you to understand why we have specific shape for the Lewis dot structure. It is because of the repulsion due to the electrons, the negative charge of the electrons. Okay, now you may have a question. The question is, well, with this, okay, trigonoplanar is on a plane. Would this go three-dimensional? Is it necessary to go three-dimensional? Well, that's a very good question to ask. Well, let's consider this. Is this the maximum angle that they can achieve? Okay, well, if we go three-dimensional like this, then this angle is maybe less than 120 degrees, okay, right here. Okay, so therefore, with 3 electron densities or less, the structure will remain on a plane. Okay, when we have 4 or more electron densities around the central atom, then we will have 3-dimensional structure. Now in the next tutorial, we're going to talk about more on the geometry because it's very important to make use of the understanding, the conceptual understanding of the negatively charged electrons, the electron density, and understand what's going on with the structure. A lot of people got confused on the structure because there are a lot of terms that are very difficult to memorize. But let me tell you this, it is not difficult at all if you understand the nature of electrons and how they would naturally repel each other due to the same charge. Okay, so if you are ready to go to the next section, just click on the next link. Thank you.